question so that the answer is not allocate a UI button, which is not the case. I've allocated a pointer to a UI button. On the right-hand side, what have I done?
Casting the sender variable to a UI button.
Casting. Exactly. So this is a C-style cast whereby sender's type, I don't really know. Because I declared it as an argument of a type ID, I don't actually really know what its type is. So therefore, I don't necessarily know what methods I can call on it. And therefore, Xcode doesn't know whether or not to yell at me if I try calling a method maybe that doesn't exist. It's OK to send messages to objects even if they don't respond to them. But if I want to really leverage my compiler and my IDE here, it's nice if it can yell at me when I'm doing stupid things. So I can explicitly say that sender is of type UI button so that now anything I do with B will be known by Xcode as referring to a button. Yeah?
Is there a difference to it inline? Like where you speed up tag, you can just cast B, the sender to a UI button there?
Good question. That would be perfectly fine. You could do this. Let me scroll over. Your code just starts to look a little less readable, but that's perfectly fine. And there's another way we could do this. We don't strictly have to say ID up here. We could do this and then eliminate this line altogether and just refer to sender. And the only reason I left it this way is really just by convention. Typically, Apple always says ID as the type of the argument and then casts it explicitly. But functionally, it's the same. The compiler won't yell at you. OK, so here now is a little grade school arithmetic that's finally coming back to be useful. Why does this line work? Well, self.amount is referring to what? I actually don't know what amount is. So what is self in this context? What class are we inside of? So this is the view controller. See, I got out of sync here with my order of operations. Let me go to the .h file, and it looks like there's a few things in here. So let's actually pause for a moment and look at what's inside of this particular view controller. So I have a property that's called account, and it points to an account object. OK, so there's my bank account. There is my controller linking to my M in MVC model. So we saw that arrow promised in the picture earlier. What's next? A long, long amount. I'm not sure why there's an amount there. So we'll come back to that. There seems to be some duplication here for some reason, but we'll come back to that. And then here's the IB outlet and the IB action that I mentioned earlier. I apparently called it balance label for the balance at the bottom and deposit label for the current number I'm typing in at the top, just like a calculator. And then I have some instance methods that are declared down here. As a spoiler, we're looking at digit, and this is the method that's going to get invoked anytime I touch a digit, a number. Deposit is when I hit the green deposit button. Clear is when I hit the red clear button. And show is just a helper method I wrote to keep my code organized and centralize all of the view code, as we'll see in a moment. So account, to be clear, is an account, a pointer to an account object. So now we go back to the .m file. And now in digit, what am I doing? I'm storing self.amount, which was another unsigned long. And I'm assigning it the return value of self.amount times 10 plus b.tag. What do you think this is doing?
So amount just holds what's the current displayed right now.
Good.
So every time you click a button, you want to multiply it by 10 because every time you click a button, then you're shifting the digits over.
Exactly.
Add the one digit.
Exactly. So when I referred to grade school earlier, I just meant to the process of every time you multiply by 10, it shifts the number over to the left. And that's effectively the behavior you want. Every time you type in an additional number, you want to shift the current numbers over and put the new one there. And you can do that arithmetically by just doing multiply by 10 of the current value and then add in b.tag. So this is curious. So b is a UI button. A UI button is a descendant from a class called UI view. And it turns out, if we read the documentation, that a UI view has a property called, take a guess, tag, which is just a number field. It's an NS integer that you can use for whatever you want. So for simplicity, what I decided to do here in my view controller is this. Notice I've got the number 7 here selected arbitrarily, but we can see it on the other numbers as well. If I go up to the attributes inspector, notice that the contents of this button are the number 7. But they could have been 7, even though that would look a little strange. But this is only to say that this is a string up here, even though it looks like a number. So that's the label of the button. But if I scroll down and scroll down, notice that under View, which is just Apple's way of categorizing attributes that are specific to UI view objects, what field does a UI view apparently also have? It's a tag. So TAG, all lowercase. This is just a property in the UI view class. That's a number that you can use for whatever you want. Typically, the cleanest way to use this is with constants that are defined elsewhere so that there's some kind of programmatic mapping to the values. But for simplicity, because this is a very simple application, I decided to just go through each of my buttons. And because by wonderful coincidence, my buttons are meant to represent numbers, I decided to assign each a tag that's identical to its label. So I manually went in and made 7 equal to 7. 8 is equal to 8. And notice that the number is going to be changing there at top right. If I click on 2, it's 2. 0, it's 0. And then notice deposit and clear are also 0. But that's not a problem because I probably wired those guys up to different methods. So I don't have to worry about confusing one 0 for the other. So if we go back to the button 7 and control click on it, notice that it will send the digit message to file's owner whenever it's pressed up inside. That means that digit gets called anytime I push a number, and we saw in the .m file that that induces a little bit of arithmetic where I multiply the current amount in that top field by 10, I then add b.tag to it, and then I call my helper method show. And show, this is not something that comes with iOS. I wrote it myself. It was just my way of centralizing all the code related to updating the UI, and it looks like this. I have 2 lines of code, even though they wrap, and I am setting my self's balance label property, the text thereof, to the result of calling NSStrings string with format convenience method, passing in this very cryptic looking string, $%LLU. What in the world does that mean? Well, what's the $sign mean? It's a $sign, money. Okay, so %LLU is a placeholder that represents exactly a long unsigned value. So if you're familiar with C, %D is what you typically use for a decimal number, but in this case we want a long and unsigned. So cryptic, but it's perfect for what we want for our unsigned long. What do I want to paste into that value? Comma self.account.balance, whose type is again unsigned long. So I called this a convenience method. In what sense is string with format a convenience method? What type of method is string with format apparently, based on this snippet? A class method. Class method because we don't call alloc, you just call it directly. So it's a convenience method, in the sense that you don't have to call alloc, you don't then have to call init and jump through these hoops, you just call this method. And again, and I think we said this a couple of weeks ago, this is a very common paradigm in iOS. If you have a class called NSString or string, having convenience methods that start with roughly the class name and then with is a common way of instantiating objects without calling alloc. So common paradigm is all. Lastly, the thing down here is identical. We're just doing the same thing with the current amount. So notice the dichotomy. I've got 2 variables called amount. One is in my view controller, and where's the other? In the account object. And notice the distinction. What's in my account is what I've already deposited. But what's in the other variable called amount, which is in the view controller, is just storing what value? What the user has typed in thus far. So if we run this thing now, even though we haven't seen quite all of the pieces, and we pull up the actual user interface, and I click the number 7, that digit message has been sent. We have done the math of multiplying 0 by 10, which is the default value, plus 7, and then I've called the show method, which updates the value to be 7. But only once I click deposit here is the deposit method called. So let's check that. If I go to the nib, and I go to control-click on deposit, scroll down here, touch up inside is mapped to deposit. So now, if I want to see what deposit does, if I go into my .m and scroll down to here, that is doing what? Self.account.balance plus equals self amount. So it's adding what's actually in the controller's variable to the ATM's variable. What am I doing with self.amount equals 0? Well, I'm just clearing my local value, and then I'm updating the UI by calling show again. So this is actually a really clean example of MVC by keeping these barriers between everything. The controller's doing all of my logic and my temporary arithmetic, but only once I'm ready to make the deposit do I talk to the model, and only once I've done that do I show things by having the controller call on the view by way of this method I called show. All right, so which method is probably going to be pretty similar? Clear. If we look at clear, super simple. It's the result of having wired things together. But suppose I've screwed up and I forgot to wire up the clear method, which I can simulate by clicking the X there. And so now the clear button has no effect. From what to what do I need to click and drag in order to reconstruct that IB out action or IB outlet? First, what is it? IB action, what do I have to do? Click on the clear. All right, holding control, go to where? Files owner, let go. There I see a list of all of the methods that I can call. The one that doesn't have a hyphen means I just haven't wired it up yet. I'm going to go do that, and now we've fixed it. Conversely, if I screwed up my label, which currently, if I click on this with control, is mapped to deposit label. How do I fix this? Well, I can control click on my label, go to files owner, and it's just the other way. So IB outlets go from files owner to deposit. There it is, deposit label, wire it up, and now I've resurrected the actual interface. Any questions? All right, so let me propose with this particular one, especially when it comes time to your native applications, if you want to start with something from scratch, think about using that as the beginnings of an application because it draws these fairly clear lines between M, V, and C, which recall is just the picture that we looked at earlier and as well last week. All right, so let's forge ahead to something that's going to give us a new capability altogether. Rather than focus on reinforcing some of the things we've done, let's go ahead and consider this. It turns out that there's a whole bunch of ways that we can start storing information. To date, we have not stored any information persistently in a program that we've written. Every time you quit the application, any things that you've been storing in variables, anything you've stored in properties just disappears altogether. But it turns out in iOS we can store things in a number of formats. So we have things called property lists, which we've actually encountered before, something called NS defaults or settings, SQLite, XML or JSON, even something called core data. So property lists, we've seen those before. What's a property list or plist file? .plist. Yeah. Exactly. It's a dictionary of strings. It's a file containing key value pairs, and we've seen this in Xcode in the form of a nice little pretty table form with keys on the left and values on the right, but that's just the user-friendly way of showing you what's really an XML file with data types like strings and integers underneath the hood. But it's useful, and if you've dived into Evil Hangman already, you know that this is the format in which we've provided you with a whole bunch of words. It happens to be an XML file underneath the hood, and you can see as much if you actually download that. In fact, let's go over to the distribution code, and if I go to cs76.net/projects, and we have the full words.plist file there. If I try to open it in Xcode, it's going to open in this big chart here, which is kind of misleading because there aren't really keys called item 0, item 1. This is just their way of representing an array in this table format. But if I instead go into my downloads folder here, and I open up words.plist with, let's say, Text Wrangler, which is just a simple text editor, we are going to see this, which is XML. If unfamiliar, XML is like HTML, but you get to make up your own tag names. And so here we have an element called array, and then a whole bunch of strings. So that is what we have given you for this dictionary, and there's thousands and thousands of lines here. So this is actually a perfect candidate if implementing a program that listed all these words, not to keep all of them around in like UI table cells if you were using a table view controller like we did earlier. So with regard to storage, property lists are nice when at least you have static information that you want to ship with your application. But they can also be used effectively to store defaults. You can store key value pairs even when an application quits. And one of the things you'll get to use in Evil Hangman or dabble with in lab is NS defaults, which is an interface for storing information persistently in applications so that when it quits, you can actually reload those same values after the fact. So what kind of uses might persistent storage like that have for an application? Why is this useful? Okay, good. So if you got a phone call, it interrupted your game, you could then reload the information that the state that the game was in so that you can continue playing it. So to be honest, you probably don't need to use property lists for that because so long as the application is backgrounded, you can keep stuff in RAM still, unless the user quits, in which case they're at a loss.
I was talking about NS defaults.
Oh, I'm sorry. So okay. So well, even NS defaults. So NS defaults are truly meant to be default values, not state remembrance for the state of a game. So defaults would be like, do